introductions to our e-board, the club, and then we're going to explain our projects a little bit, have a pizza break, and we will have a guest speaker. So who are we? We are the UCF branch of the American Institute of Aeronautics and Astronautics. We are a project-based aerospace club. We focus on offering y'all beginner-friendly and experimental projects so that you can get more involved in the world of engineering and aerospace here at UCF. We do professional development as well and some socials, so definitely be on the lookout for those events as they come up throughout the semester. We are also one of the largest chapters of AIAA in the nation, so it's great to be a part of this community. We've got a lot of people that you can network with and interact with throughout your career here at UCF. So this is our e-board this year. I'm Amelia Soriaga. I am your president this year.
I'm Austin Fleming, your vice president.
We've also got Ethan Scheller, your secretary. Valeria Snadarsic is your treasurer. She's actually at Costco getting you guys pizza right now, so she's not here. And we've got Connor Tyson, your project chair. So a little bit more about me. I am an aerospace engineering major here at UCF. I'm a senior, so this is my 4th year here in AIAA. I've done pretty much every project that this club has to offer, including quadcopters, rockets, hovercrafts, you name it. I've also been the secretary. I was the secretary last year. And of course, obviously, I'm the president now. Some of my hobbies outside of school and outside of the club are rock climbing, traveling, and nature walks. And then a fun fact about me is that I have driven to and from Chicago over 20 times in my life.
Once again, I am Austin Fleming, your vice president. I'm a senior in aerospace engineering here at UCF. This is my 4th year at AIAA. I started in aviation vehicle design as a freshman, and then I became the lead for that the past 2 years. I've also participated in rocket design and DBF. Outside of club and school and work and whatever, some of my hobbies are building cool things. Well, I am in engineering, most of y'all are, so that's what we do. I also like to do photography, and I also run. A little fun fact is that I co-founded a company in high school that is actually still running to this day. Since Valeria is out of town in Costco, I'll be doing her slide for her. She is also a senior in aerospace. This is her, I think, 3rd year here at AIAA. She has done rocket design, L1, hovercraft design, and design, build, fly. Her hobbies are horseback riding, boxing, rock climbing, and her fun fact is she has unlimited lore.
Hi guys, my name's Ethan Scheller. I'm the current secretary, so I have big shoes to fill from our president. But yeah, I'm also aerospace engineering. Big shocker there. I've been in the club for I think about 2 years now. I was previously a hovercraft assistant lead, so I have a soft spot in my heart for that. But I've done hovercraft. I did rocket design with our great rocket leads, and I'm doing design, build, fly this year. Did it last year as well. Some hobbies, I play guitar, enjoy it a lot. I do a lot of sailing, pretty cool picture up there. I love riding my bike, and I love eating Culvers, and that is something that's very important to me. Fun fact, I'm on the UCF sailing team, so I like to get out there and sail. That's pretty much it.
Hi, I'm Connor Tyson. I am an aerospace engineer. This is my junior year. I used to be the quadcopter design lead. And also, I built a lot of RC planes and quads. I like doing photography. Yeah.
So that was our e-board, and I'd now like to introduce our faculty advisors. We have Dr. Kaufman and Dr. Parati. Both are MAE professors and both have extensive backgrounds in engineering, both having PhDs, whether it's in aerospace or mechanical. They are pretty much the backbone of this club, and we love them. And with that, we have our committees. First up is going to be media. Media is where we're going to have all of our photographers and videographers basically just highlight the club as a whole. And then other than that, we're going to have our social media and graphic design post those, as well as make flyers and basically just give out information all to the club. So the wonderful flyer that you guys may have saw on our Discord and or on the bulletin boards around campus was built by our graphic design team and also posted by our social media team. Next up, we have events, and these people are going to be involved of all of our socials outside of the club, whether it's future bowling things or coordinating events for fundraising that we have if you ever seen the ducks for Valentine's Day or the boograms in the atrium, that's us doing those, as well as they do that and fundraising outside of the club. Also fundraising is sponsorships, and this is where a lot of our money comes from for these projects, because they do cost a lot of money, especially some of our experimental projects. So we're looking for somebody to join us as a whole to reach externally out to companies and get some funding, whether it's money and or materials and or even time in a lab somewhere that has a manufacturing lab. This is a little rundown for you guys to read over for you guys if you want some more information, but there will be a QR code at the very end of our slides to apply to these for if you want to.
All right, and I would like to welcome up Skylar from Events Committee. All right, and of course, because all of you guys are interested in projects, right, we've got to have our project leads come up here and introduce their projects for you. So first up, we're going to have our aviation vehicle design leads come up.
Alrighty, so some of y'all might be wondering, what does aviation vehicle design stand for? Or AVD stand for? Oh, there we go. So before we start that, I'm Chris, I'm the lead.
Hey everybody, I'm Nelson All. I'm the co-lead.
Hi, I'm Ian. I'm one of the assistant leads.
I'm James. I'm also an assistant lead.
I'm Daniel, and I'm the final assistant lead.
So with aviation vehicle design, we're exactly what it sounds like. We're a 2-semester project. We go through the research, design, analysis, and manufacturing of small model planes, just like this one. 4-foot max wingspan. And so the first semester, we get to research, and we get to design. We use tools, SolidWorks, XFLR5, airfoil tools, to learn how to actually design our plane. And then second semester, you get to 3D print, laser cut balsa wood, and put skin on your planes. And then we actually go fly them in a competition. So yeah, great club. Nelson's going to tell you what our competition actually is this year.
Absolutely. So the competition this year is going to be top speed, but instead of it only just being a top speed goal, we're going to include weight. So when you design your aircraft, you're going to be focusing more on the aerostructures as well as the aerodynamic design. So it offers not only an opportunity for aeros, but also mechanical if you're interested. So we have one course that we run, and it's at an RC field that is, I think it's around 500 yards. And you do a couple laps, we'll get your speed, and then once it'll return, then we will put the weight in and then do another round. So once that is done, we calculate all the scores. That's fun and competitive, and then we'll announce the winner on Discord.
And it's important to note with this project, you need no prior experience. We will teach you how to use all of the software, how to run all of the analysis, and build your plane yourself. So if you're a freshman or if you're new to software, we're here to teach you. This is a great experience to get some experience that's actually applied in industry. So love to see y'all there. Our first meeting is going to be Monday from 7 to 9 p.m.
Thank you so much, AVD. Next up, we've got rocket design.
Is this even working?
Yes.
You go over there. You're going to explain all once. Okay, that's fine. Yeah. All right. Hi, everybody. So
We are the leads for the rocket design project. I am the lead, Nikos.
Over the mic. I'm the co-lead, Alex.
I'm one of the assistant leads. I'm Nathan.
I'm also assistant lead, Jonathan Nicholson.
I'm Anthony. I'm the third assistant lead. We got a lot of us.
Fun fact, they're cousins. That's why they have the same last name. All right, so a little bit about what rocket design is. Basically, we take you through the full process of designing, simulating, manufacturing, assembling, and then eventually launching your own high-powered rocket and mid-power rockets. For the rocket design portion, it's kind of how it kind of works is you're in a team of 4 to 5 people to design a rocket, kind of like this one right here. And yeah, you're going to launch it to right around 1,000 feet. And then along with that, we also do L1 high-powered rocketry certifications, which I highly recommend doing. Looks really good on a resume. And Alex is going to tell you guys a little bit more about that.
The other important thing Nikos forgot is that the rockets that you'll be launching, you'll hopefully be getting back. So that's a plus and a bonus that you get to keep from this project. But yes, hopefully, if everything goes to plan. But this semester, for anyone returning, we're going to be running rocket design a little bit differently. We'll be going through the mid-power or like beginner level rockets for the first good portion of our meetings. And then following that, for anybody that's looking to do a high-powered rocket, get what's called the L1 certification that he mentioned, something, again, that looks great on a resume. You could stay after for a little bit more instruction. In the past, normally we would only be doing rocket design in the fall and L1 in the spring. Now we're kind of combining both so you can participate at the same time if you want. Both are optional. We're going to be providing just a little bit more knowledge and experience following those rocket design meetings. So definitely sit in on the mid-power group if you're looking to do the L1 HPR as well. Anything else?
Beginner friendly. That's a big thing. No experience needed. We take you through literally everything that you need from doing the initial designs, learning all the information you need, literally rocket science. So there's a lot to learn and we take you through all of that. A lot of information that you don't typically learn until some of the later classes. So yeah, a lot of great experience.
First meeting is on Tuesday at 6:30 to 8:30 p.m.
All right, thank you so much, guys. Next up, I'd like to welcome up our quadcopter design leads.
Good evening, guys. My name is Luis. I will be the quadcopter lead for this year, taking over after Connor. And this is...
Hi, my name is Ellen. I'm the co-lead for quadcopters.
All right. So quadcopters is a beginner-friendly project, just like the previous 2 projects. We pretty much walk you through the steps of building a quadcopter. It's a 5-inch quadcopter, and it has FPV capabilities, which is the fun part. I will have Alan tell you a bit more about it since he was in the project last semester.
I was on there last year. So with quadcopters, we will be helping you. We'll show you how to download and use SolidWorks. We are going to help you a little bit with the basic CAD and mechanical design of it. We're going to teach you a little bit about the electronics behind it, kind of wiring all that. How to do it line of sight and through FPV using the VR goggles.
Yeah.
It's a really beginner and simple project, so this is definitely suited for people who've never done a club project before, so no experience required. This is, we welcome freshmen. We want as many new engineers as possible. This is great for you guys.
Yeah. That's about it for us. You can see our meeting times up there, Monday, 6 p.m. And in case you can't make it that day, we have Wednesday as well. That's about it from us.
Thank you so much, and welcome up hovercraft design.
Hello, everyone. It's not just me. It's just that our lead is in a lab, so he didn't want to miss the lab, of course. Okay, his name is Vivek, and he's going to be the lead, and I'm Sebastian Madrid. I'm the co-lead. So hovercraft, if you wonder how hovercraft looks, you can later come in front and look at the last vehicle right there. This is a very, very beginner-friendly project. If you maybe have too many classes this semester, or maybe you want to start with something simpler, you can go and join us. It's going to be pretty fun. Uh, Most likely this semester is going to be, we're going to do with like a small soccer tournament with the hovercrafts. So if you like soccer, you can also join us. Okay, things that you will learn for sure. We mostly use Fusion 360, and you're going to learn RC electronics. Also, if you were wondering, for the Fusion 360, you're going to cut plywood, so you play with it. Well, not play, but you can see the laser cutter on the TI Innovation Lab, which I think is great. Yeah, that's it. You can look. It's pretty fun, guys. Come and join us. If you have any questions, you can later ask me any questions or ask our secretary. He's also going to be kind of a mini lead for us.
All right, thank you so much. Next up, we've got some experimental projects that are new this year. So first up, I would like to welcome up V.
Hey guys, my name's Tiago. I am the VTOL project lead.
I'm Dante, the assistant lead.
So let me tell you guys about one of our new experimental projects. So experimental projects, unlike the guided ones you guys just saw, are ones where you guys as members will directly contribute to how the project turns out. They're not guided experiences, so freshmen might be a bit more challenged in this one, but if you're feeling really ambitious or you have previous experience, there's no hard requirement for joining, so anybody's free to come in and see how it goes. With this project, specifically trying to make a convertiplane VTOL that can convert between vertical takeoff and landing and horizontal flight seamlessly and do it back and forth. We have some specific mission requirements that we'll go more into during the first meeting. There's a lot of different kinds of VTOLs, so we're limiting it to 3 possible design choices. We have tilt rotor, which is kind of like an osprey, kind of like the top picture you see there. We have tilt wing, which is the bottom right picture, similar to an osprey idea, but the whole wing itself tilts. And lastly, lift fan, where you have 2 separate propulsion systems for the 2 different modes of flight. And the thing about that with the different design choices is you guys get to decide which one we go with. That being said, we have 3 sub-teams for this project. We have an airframe team, propulsion team, and a controls team. So it's very interdisciplinary. So anybody, no matter what discipline you're from, is more than welcome to join. And we really need controls people especially. And like I said before, you guys get to say in this, so it's a very research and development heavy, and you guys are going to learn a lot of experience from this that you'll probably take into your first job. See you guys on Monday.
Right. Next up, we've got our other new experimental project, Project Horizon.
Oh, I get both? That's awesome. Okay, sweet. Hello, everybody. Welcome in. Everybody here actually, super interested in rockets. Is anybody in here interested in big rockets? More? Did more hands go up? That's awesome. All right. We all know the coolness factor of the rocket scales with its potential for, combustion. So, of course, my name is Dylan Moga. I'm the lead of Project Horizon. And Project Horizon is sort of a project that we've kind of had cooking up in the past 2 years. We've been leading rocket design. What that is, large-scale rocket, and we're targeting up to a 45,000 feet apogee, and up at that apogee, capturing a view of the horizon with an onboard camera and live streaming it down to the ground. Now, as you can imagine, catching stable footage on a rocket going that speed and going that high up it's a bit difficult. You got a lot of spin just from little aerodynamic imperfections. So that's why we're also going to be incorporating an onboard reaction wheel system or actually stabilize it. So that is actually active control running through a computer through the whole project. So we've got a lot of cool, interesting engineering design challenges. As of right now, we're doing a lot of work. We're kind of neck deep in research with a lot of our teams. We're looking for anybody who's interested in getting involved in something that sounds as cool.
So similar to VTOL, we're splitting up the project into sub-teams. So we have propulsion sub-team, an aerostructure sub-team, avionics, payload, and then finally a systems sub-team. So you're free to join one, join multiple, whatever workload you can take on. We're welcome to have you.
Glad I got that.
All right.
All right. And of course, last but not least, we have our singular competition project, Design, Build, Fly.
Hello. I am John Bradley. I'm the lead for this project, and this is Ashlyn Foster. She's the co-lead. So what makes DBF different from AVD? We are like the next step from AVD. So DBF is a senior design project. A lot of the e-board, it's their senior design project. It's also a competition project that's put on by AIAA National. So all these people here, it's an international project. So everyone submits a proposal. They choose the top 100 proposals, and those teams go and compete, fly off in Kansas in April. So international competition, you get schools from like Europe, some Australian teams last year, but a lot of involvement. So if you've done AVD or had previous experience coming to school with SolidWorks, any eCalc, anything like that, this is a great opportunity for you to use those skills at a higher level. So we got this year's mission requirements already. I'm going to turn it over to Ashlyn. She's going to talk a little bit about those.
So DBF is going to be your more advanced, more fast-paced. We've already kind of started project a little bit. Meetings will start officially for members as of next week. With that being said, we are running really quick. We are little more advanced, so more experience the better. Our missions are going to be, obviously, first one's going to be test flight. You got to make sure the plane flies before it can do anything else. Second one is we're holding passengers and cargo, so we're looking to make restraint systems this semester, as well as cargo bays, separate from everything else. And then last but not least is deploying and releasing a banner mid-tow. So creating mechanisms, mechanical systems, and everything like that, as well as electronics are going to be needed. But like I said, very fast paced. Projects already starting up very quickly, so the more advanced, the better. CADing, anybody who knows electronics really well, that's going to be a big thing. But other than that, that is our project.
I'd like to give one more big round of applause to all of our projects. And with that, we have merch. If any of you are interested in merch, we have plenty of options for you guys. We have last year's shirts. We have flight tags, polos, stoles for any of you that are graduating soon. Next year, if you want to get it now, by all means. We also have mystery bags, which is going to be an opportunity to get previous year's shirts at a discounted price, a lot cheaper than the original ones that we have now. So if you want to have any merch, they'll be on our website, and you can find that website at the end of the slides.
And of course, none of these wonderful things come to you all for free. So I have to talk about membership a little bit. We've got membership dues. They are $30. They cover you for 2 semesters, and that's going to cover your participation in any of our projects, no matter how many you have time for. If you want to do all 7 of them because you somehow have time for that, you're welcome to do that if you pay the $30 membership. Also covers you for some of the discounted prices for our social events, if you want to come to our professional development events, or if we do any industry tours as well. And we are a part of a larger national organization, so of course they have their own membership as well. For students, it's also $30 a year for their membership. They do some more professional development stuff. There is plenty of professionals in industry that are involved with AIAA National, so that is going to span both your career as a student and as a professional in industry, whereas we are more here for your career here at UCF. But if you are interested in being on the official roster for our Design Build Fly project as an undergrad, we do need undergrads for that project. And to be on the roster, you have to be a dues paying national member for that. Also, if you're interested in going to SciTech, which is going to be in Orlando in January, you can get discounted rates for tickets for SciTech using their membership. And of course, what you guys have all been waiting for, the pizza break. We are still, I believe, waiting on our treasurer to get here with pizza, but once she gets here, we will start that. Where the fuck is she?
How about now? Good? Okay. Good evening, everyone. Thank you for having me here tonight. My name is Jerry Sproul. I'm currently out of Titusville, but I'm mostly here today to talk about my time at Northrop Grumman. I spent over 4 decades in various roles, starting out in engineering, doing a bunch of things. We'll talk about that in a minute, but I certainly wanted to kind of... Okay, we'll do. Got it. Reposition, got it. Let's talk about a little bit about my background and kind of work through some of the discussions in my career, and see if we can translate that into any observations, lessons learned, perspectives, not necessarily counsel, but things you might want to think about as you kind of work your way through the career. A couple of things to kind of kick it off. One is last summer, I was at a meeting with the president of AIAA National at Cape Canaveral, and at the end of the meeting, he says, "Hey, by the way, we're having a social for the local collegiate community at the Cape Brewery or something there, right there in the Cape." And he goes, "You should go." So I went to that, and now I'm here. So, but it was good to meet some of the AIAA UCF folks there. Had some really great conversations, and it turned into a couple of different conversations and tireless follow-up with me to make sure that I didn't let this opportunity pass me by. Looking forward to having this conversation with you guys and gals tonight. Let's see here. Cool. So I'm going to kind of touch a little bit on what I called here my journey, but that's not to say, hey, look at everything I did. It's more of to give you a context and background, so when we get to the perspectives that I had taken away from that journey, you have a sense of where that's coming from, what my experiences were. And there's a few kind of fun highlights in there that are kind of fun to talk about that I certainly want to kind of touch on as we get through there. So AIAA, I'm certainly on the aeronautics side of things. That's certainly been my career path. So you'll see heavy aeronautics flavor to my career. So a little bit of a kind of a quick timeline. The next page, I'm kind of going to walk through it. You kind of get a sense. I've been at this since, you know, a long time, and all the way back to the early 80s. When I graduated college in 80, went to work for then Grumman Aerospace, and I retired just about 2 years ago. So that's, if you doing the math, that's about 43 plus years with the same company, and I'll talk about that also in a minute. Kind of a lifelong learner, been back to college multiple times to Thunderbird School of Management, the Defense Acquisition University, Embry-Riddle, got my graduate degree from Riddle, and my first foray into that was with DeVry University in Atlanta. And you can kind of see stepping through engineering, management, site management, ultimately strategy and business development, things of that nature. So I've had a kind of a technically underpinned career. About the first half of it mostly engineering focus, the second half of it strategy, management, engineering, project management, and program management on the back end of my career. So with that, I decided to kind of do a little bit of a pictorial thing to kind of call out some things along the way. I kind of broke it down into early, mid, and late. So early career, that very young man there, that's me, believe it or not. I was doing field engineering for, again, then Grumman Aerospace. So I had about 7 straight years of deployments on USS aircraft carriers, military aircraft carriers, twice on the Forstall, twice on the Saratoga, and once on the Eisenhower. Kept me busy for about the first half a dozen or 7 years of my career. And if you picture if you've ever seen any of the stuff in the movies, the fast pace of the flight deck and the flight ops and everything going on, and the unique characteristics of arrested landings and catapult launches and all the aero design that goes into that craziness, kind of defined my first half of that. And I remember things like sitting inside the air. I'm not a flight crew. Remember, I was doing engineering work, so I was supporting the Navy as a civilian on that particular aircraft there, which is that particular picture is of an E-2D Advanced Hawkeye, which is a U.S. Navy airborne early warning radar platform. At the time, it was an E-2C, same look, different variant. But I would do things like I'd be sitting inside the aircraft while the aircraft was on the catapult ready to launch, and there'd be some system down, and I'm on there trying to get it going so that we can get off the aircraft, button it up, and launch it off the pointy end of the boat. So it was a pretty interesting and exciting time of the career, and definitely something that got me around the world to countless places that I've had lots of good fond memories of, as well as some challenging problems to solve on aircraft. From there, the travel got to be a bit much, so I decided to kind of anchor for a bit. So I picked up a role with the Singapore Air Force, and I moved to Singapore for 5 years, supporting the Singapore Air Force in their operation of that very same aircraft. This is their variant. You can see the yin and the yang on the side that the U.S. Navy was flying, supported them in country. That was an interesting thing. I'll give you kind of like a data point. Is my customer who was in charge of the radar operation and maintenance for the Singapore Air Force had a PhD in radar engineering from Sorbonne in France. So he was a very, very well-informed customer, and it made me be on my A game for the entire time I was on the ground there. So that was an interesting place to live, a lot of fun, and the only reason I left is because the contract was up. Moving on from there, transitioning back to the States, I wound up in Melbourne, just over here on the coast. So then Grumman Aerospace had just opened a new facility there. And it was because they competed against the Boeing company and won a competition for a platform that was known as the AIAA Joint STARS, Joint Surveillance Target Attack Radar System. So that's an air-to-ground radar surveillance platform based upon a commercial aircraft, in this case a Boeing 707, but it was a military derivative that we created out of that commercial platform. And so I spent a lot of time doing system integration, design, tests, software tests. I worked on the communications system design team back in my early phases there, working with the comm systems. Ultimately got deep into test and integration, wound up running the labs and then running the test department from there. And that got me into engineering management, which ultimately put me on a course to be the test director for the E8C platform. But in the middle, a 4-star Army general by the name of Norman Schwarzkopf during Desert Storm 1 decided he needed this capability in the war. We were flying aircraft that were designated experimental we were carrying experimental aircraft certification from the FAA, so they weren't even fully flight qualified articles yet. So we took the 2 E8As over to Desert Storm, and I had the opportunity to fly combat missions during Desert Storm because the only people who knew how to operate the system were the Northrop Grumman engineers because we were just designing it. It hadn't even been trained with the Air Force or Army yet. So off we go, and away to war we go. Again, fascinating time, fascinating sideline during that phase of my career. Came back from those E8A missions, and we we only built 2 of the A's. The Air Force said, we like them, we're going to buy them. Now we want to update everything, get everything the way we want it, and we're going to call it an E8C, and that's when we're going to go into production. So that's when I became the test director for E8C. For the aero types, so a Boeing 707 has very known, decades-long, well-understood flight characteristics. But throw a 24-foot canoe, and you can imagine the crosswind loadings associated with short final, trying to land that thing in a crosswind becomes a completely different animal altogether. So we had lots of aero, lots of flight tests, about a 7-month-long flight test program on an aircraft that had been in production forever, right? It's not a new airplane. But just that one modification changed the characteristics so much that it took us a lot of time and energy to work through getting that to work correctly and to behave in a way that the pilots understood what it took to land in adverse conditions. From there, wound up doing program management for a while. And then I became the international program manager for that same platform and was responsible for a whole series of countries there that were owner-operators of that same platform. And we're solving engineering problems, operational problems, logistics problems, you name it, a very multidisciplinary kind of program management role that I rolled in through that. And then later on, I wound up getting into strategy and business development. So I did a lot of time on the ground and actually all over the world. I had folks that worked for me in seven different countries kind of thing. So it was a very much a time zone challenge role, but very interesting. Got to meet a lot of interesting people. As part of my industrial partnership outreach, we were having a conversation with Zero G. If you're familiar with that, the vomit comet is what the astronauts call it, but that's the weightless flight experience that they do. I got to actually do that out of Titusville, which was it's all it's cracked up to be. It was pretty wicked cool. So that was fun. From there, I moved into more of an executive management role, and I was responsible for Northrop Grumman, all of aerospace systems, the entire sector, for both manned and unmanned aircraft, new business, internationally focused. You can see the Triton. That's high altitude, long endurance, or a HAIL UAV, 65, 70,000 feet, stay up for 24 plus hours. That, and we also had the venerable, you can see the common theme here. I've always kind of hung around that jewel there, the Hawkeye, and had responsible for about $3.5 billion of new business over kind of that period. Then I shifted gears entirely for the last 5 years of my career and went to integrated air and missile defense, command and control, and then counter drone. So I spent the last 2 years before I retired coming up with different ways to knock drones out of the sky. So in retirement, we'll make short of this one, certainly have my own shingle, if you will, but as you saw on the title side, I do most of my work today for BC Consulting out of Boston. I work for all the major primes, the Boeings, the Lockheeds, the Northrops, you name it, that are out there. Do some work for a company called Lone Star Analysis out of Texas, and Space Tech. I sit on the board of directors there out of Titusville. So that's kind of a snapshot of what I was up to over those 4 decades, and through that time, all the way to today, that engineering technical underpinning, that engineering prowess that I developed back here, but more specifically in my particular case, the cross-disciplinary skills that I developed, whether they be the soft skills or understanding other disciplines outside of my own swim lane, is what ultimately created this path for me in my career. And we'll talk about that here in a second. That's a quick visual journey of the previous chart. So with that, I hear this all the time. You stayed where? How long? Are you kidding me? That's ridiculous, right? But the interesting thing about it is, a company like Northrop Grumman, you think about it as Why you stayed at one company for 40 years and you never thought to leave? The question is it really one company? This is a snapshot of how Northrop Grumman became Northrop Grumman. So I entered somewhere around here. So you can see all of these companies on this chart represent who and what Northrop Grumman is today. So to say it's the same company, I can tell you as a guy who lived this on the inside, couldn't be farther from the truth. It was ever-changing between mergers, acquisition, divestitures. The company was morphing and changing all the time. So at times I was Army customer focused, other times I'm Navy customer focused, Marine Corps, you name it. And I've had them as a customer in technology as well. Aero, electronics, integration, networks, AI, you name it, you pick the tech base, and with the exception of space, excuse me, which is an area I'd never dabbled much in, but on all the air breathing side, I've touched most of the aspects of any particular design that you might want to see over the years, all brought together by this very, very broad set of companies. These are all today Northrop Grumman. So what does that mean to this conversation? So I scribbled down some thoughts. So I'm going to kind of go through these, and hopefully I'll get to the end of this, and we can have a conversation, do some Q&A. Here, what you're doing here now, you're building your fundamentals. You're getting your academic acumen dialed in. You're figuring out the discipline of interest and study. All those things are true and definitely are critical to succeeding as you work your way through your 4 years here. Make sure I don't miss any of my notes. Be hands-on. You heard all the mentions of these projects. I wasn't even aware they were going to brief them tonight when I wrote that bullet, but I'll tell you, my lab time during my different collegiate experiences was where I really translated all the late nights of homework and math and lectures into what does it mean? What am I going to do with it? How does it translate into something real? And I will tell you, nothing locked in my academics better than applying them. I can't, foot stomp. So these opportunities with these projects, aside from sounding really cool, a couple I want to talk about, and I think I want to get involved with a few of them, but definitely some cool stuff. But nothing better than to lock in your academics than applying it to a real world situation and working on teams. You're sitting alone at night cranking through the books, but when you get to your workplace, eventually you're going to get assigned to a team. So developing those skill sets, those soft skills on how to talk to people in your own discipline, excuse me, I got a tickle, how to talk to people in other disciplines, how to talk to people outside of engineering who also have a vote. Maybe they're managing your budget or human resources, or pick a thing. How to interface with that collective that ultimately will define you as a team cannot be, again, a foot stomp almost as hard as I foot stomp the project than the hands-on piece. Those skills that you can develop here working with these projects translate hard into your employed life when you graduate and get on with your career. So that think beyond the academics when possible, a way to do that is get involved with projects that apply your academics in a real and very meaningful way. Networking. You guys say more? That's why you're here. Part of the reason we're here. Peers, professors, alumni, conferences, associations like this one, et cetera, are absolutely ways to start, build, and maintain a network. There'll be resources for, I got a problem that I'm having trouble solving. You know what? I think I'll call Amy. No, I think I'll call Matt. I remember us having this one. He or she might have something to offer. They can be within your company. They can be in another company. There'll be proprietary boundaries. Just let's put that aside for a minute. But you'll just always have the ability to interface and collaborate with people, both within your companies that you'll be with and on the outside as well. Mentorship, maybe a little bit later, but something that I've done for my entire career is both be a mentor and have a mentor, right? That's a good way to have deep and meaningful relationships with people that you can benefit from being around, and also they can benefit from your background, unique skills, experiences, etc. It's good to have that those relationships. Career path planning, let it evolve. Always have a plan, but don't rush it. That's a natural thing to do. Is says, okay, where's my next rung? Focus on getting good at what you're currently doing before you start figuring out you're spending less time worrying about your current job and more time about worrying about what's next. I always did that in my career. And in almost every case, when I got really, really good at what my assignment was, excuse me, it'll pass, I'm sure. Once I got really, really good at what I was doing, I usually got sought after for the next thing. I usually didn't even have, I have to apply for very few new jobs in my career path because my work spoke for itself. It didn't cause an outreach to me to say, hey, we got something that we heard about you over here. We think we can use your help over there. Also, what's your brand? Who are you? What are you going to be about? Are you going to be the best individual contributor? You're going to be the best scientist on this particular architecture, technology approach. Nothing wrong with that. I'm getting really, really good at something and then becoming the worldwide expert on it, or the regional, or even within your department, being the expert on something. The go-to guy or gal for a particular thing is a great place to be, but it's not the only place you can be. You can be research, and you can be on the product side. You can be a person that has this entrepreneurial spirit, and you want to go get involved with some startups. You have management aspirations, or something that's not even represented up here. But be thinking about those things because you definitely want to have a sense of how you want your peers, your leaders, your network to kind of view you. Do they want to view you as the expert? Do they want to view you as we got to get that person on our team because they really, really are good at working and bringing out the best of the team? Sometimes they're not the same person. Just because you're the expert doesn't mean they want you on your team or not, right? So those things are all things within your control to develop. But I just suggest that it's something you consciously are aware of as you work through it. Teams, we talked about that already. Building your personal brand, kind of back to here as to what do you want to be known as? For me, it was the multidisciplinary team player is what I really kind of focused on in my career, and what it wound up leading me to some new and interesting places over the period. I got really good technically, but I got really, really good at working and leading engineering teams. People skills, communications, teamwork, writing, time management, all those things sound like really, but they're very, very important in the workplace itself, right? There's things like writing and stuff, being able to well document your work and well report on the results of some testing or some prototyping, and a way to kind of write that up so that the reader on the other side, the consumer of that information, says, this is a well-structured, I can understand it well, it reads well, it flows well, etc. Is not everybody has that knack, and for me, it's not natural. For me, it was a very hard-learned skill for me personally, something I ultimately got good at, but it was a hard road. I got a lot of feedback along the way. And then life basics, they matter too. They call it work-life balance. They call it life balance. They call it a lot of things kind of come into play there. You know, money, family, your health, all that kind of stuff matters. don't forget to kind of, you're a whole person, and kind of keep an eye and keep a balance on all those kinds of things. Travel, I tell this to my kids all the time, and they all have and they continue to travel. It changes you in a good way. It gives you a different perspective on the very life you're leading, kind of thing. So I can't stress that enough. If you have the opportunity to travel, and of course, call it the dad gene, call it what you will, but it's certainly the conversation I've had with my kids and many people that I've mentored and young professionals and stuff. Start saving for your retirement on day one. I won't give you a financial lecture on that, but if anybody wants to just kind of look up time value of money and compounding interest and just do a little bit of the research there, you'll go, wow, I see what he's talking about. The earlier start with a nickel will be better than $1,000 a decade from now, right? So so that's those pieces as well. So these are kind of some things that I thought about through my career that I've thought were things that either I had influence of or influenced or shaped my decisions, my brand, who I was, and how I became the engineer, the leader, and ultimately the executive at Northrop Grumman that I became. So with that, we talked about getting involved. These were my associations. Some of them, probably a third of them, are still active over the years. So AIAA here, sure, that's great. There's a lot of them out there. So as you move forward and you find something that's a niche that you're in, there's probably an organization out there that has even a niche professional association aligned with your particular area of interest if you start to specialize. Mine actually, oh, right in the middle. The Association of Old Crows, which is electronic warfare or electromagnetic spectrum warfare today, but it's EW. That's the one that probably the whole middle part of my career was kind of defined by. So in addition to some of these other ones, where I was very early in my career, that was the International Association, etc. But these are great places. I have relationships that I built 30 years ago, 40 years ago here, that are still resources for me today to reach out to and help me with whatever it is I'm looking at. So networking, I can't oversell. So with that, I'm ahead of schedule, which is awesome. I wanted to leave some time for some Q&A at the end, and the floor is open to you guys, and it can be on pretty much anything. So any questions? Yes. So when I there was a model rocketry that I did at Riddle, and then when I was also at DeVry, there was a it was a at the time, I think you really call it a kind of a circuit design competition kind of thing. That was kind of like a boring side job, but the more interesting one was one of my professors, John Blankenship, was created a kind of an after school. It was a bit of an ad hoc club at the time, but he was writing a book called The Apple House, and this was before Mac was invented. So this is really early Apple days, and he was designing a robot. Tim L, truly intelligent mechanical electrical life. His robot name was Tim L, and he got a group of students together that were interested in doing something after school, extracurricular, and I was on the team that wrote the speech software for his robot, as an example. We did that for after school for 10 months or something like that. It was a long project, but that was probably the biggest, deepest engagement I had on anything that you guys are talking about like that. Aside from that, it was the normal clubs and social activities and things of that nature. But the things that were hands-on application were the ones I just cited. Yeah. Say again? I did not myself, but I was actually little early story that kind of became a bit of an internship kind of event. I was home at Christmas break before I graduated in the spring of the next year, and I ran into an old neighbor of a relative of mine. Just this obscure story. He worked for Grumman Aerospace, and ran into him, and we're talking, and he says, "Hey, what are you doing?" I said, "I'm graduating soon." You can imagine the conversation, normal stuff about where I was, what I was doing, and he went, "Huh, I wonder." Because everybody that worked for him on the Hawkeye program was generally prior Navy, technical technicians and stuff, prior Navy, that they brought into Grumman to go support the Navy. They never got anybody with a true engineering background and try to teach them how to be involved and participate with the Navy, because that's something you can't. It's hard to teach, right? You either went through all the rigors of becoming part of the Navy, but it's hard to just explain that to someone and then ask them to go do it. So I was kind of brought on as a bit of a test case. So I had about a 6 months period of this kind of probationary, interny kind of feeling kind of thing where I was mentored. I was assigned to different people. I did a tour through 3 different departments up in New York, where the headquarters of Grumman was. I got sent down to the operating site at NAS Norfolk, Naval Air Station Norfolk, which is where the Navy operates the aircraft. I got assigned to night shift, different engineers, just kind of staying out of the way and just kind of learning the ropes. And about 9 months into that, they put me on a ship and sent me out to sea. 2 years later, I was the team leader of my 3rd deployment that went out. I was the team leader on. So it was a pretty quick study, but they did treat me as an intern, even though it wasn't an internship. Oh yeah. There's an old saying, and the saying goes, people don't quit jobs, people quit people, right? And what's meant by that, and you can probably just understand it on the face of it, but I never had a job that I really didn't like, but I've been in teams that were caustic. I've been in teams that were just bad, just really, really bad. And even late in my career, even as a very senior person in the company, everybody's got a boss. Even the CEO works for the board. Everybody's got a boss, right? And I found myself doing another leader a favor and making a move to a team. Worst move I ever made. It's why I retired, quite frankly. I mean, literally, I'm being very honest with the group here. And I got into a situation where the work was good, the work was interesting, it was meaningful, and it was important to the warfighter. But nah, it wasn't for me. So I would have had a different path toward my end had I not made a decision. And if I'd have done my homework, I would have known the people problem. Was knowable before I made the move, but I didn't do all my homework, and I wound up getting myself aligned with the wrong people, and that set me back at the end. So I retired before I was really ready to. It's fine, but people quit people. They don't typically quit jobs. So who you work with and who you work for matters a lot. Second row. Hi, Evelyn. Yep.
Is there any advice that you would give, like, people our age, Gen Z, on like what you see in interns when they come over to your company that makes them stand out?
Absolutely. So take the internship seriously. Be serious when you're engaging. I don't mean stoic. I don't mean fake, whatnot. But remember, if you're in the doors of the office, people are developing opinions. You're being evaluated. That's what the internships are all about. And at the end, they decide we're going to keep this bunch, and you guys have a nice life, right? That's how it works, right? So having run internships, sponsored internships, brought interns in myself, et cetera, having done all that over that career, I can give you very, very specific advice on that. Take the job seriously. Think about your speaking, right? Collect your thoughts, and then have the conversation with somebody that you want to have about a particular topic, and mostly just kind of think about, this is a serious situation you're in, meaning can define the course of your very career, and how you present yourself, how you show up, how you look, how you talk, how you engage, how you frame problems, how you frame answers, how you ask questions, all matter. And everybody in the room that you're hanging out with is going, oh, okay, yeah, let's pay attention to that one. She's asking good questions, and not just to ask a question, just to ask. I know those people too, right? But asking the question that's relevant and germane to the point and adds value to the room. That will make a difference. So how you show up matters, and be aware of yourself and your surroundings and how you're carrying yourself during the internship.
Other sort of STEM skills are valuable, like from your experience in like the aerospace industry?
So other STEM skills, did you say, or I'm trying? Well,
mostly like other engineering skills, like what companies.
Well, that's interesting. So these days, the lines get blurred a lot, which is probably where you're coming from, right? Is it used to be an ME? Well, you go sit in that corner, and here's your AutoCAD, and when you finish designing the thing, we'll take it and we'll take it to the other team. That's not really the case anymore. There's much more. The tools today are much more integrated, much more collaborative. Multi-disciplines are working on the same common set of data. Right, and so design data, and that all comes together in a singular design. So I don't know that you need to become an expert in anything other than the thing you're saying I want to go be, right? So if you want to go be an aero or whatever your particular path is, that's fine. But don't forget to get enough learning by either collaborating with, taking a class or two, whatever, in disciplines that are adjacent to and related to your field of interest. So I would say that kind of think about if you just want to be aero, you probably want to understand a little bit about power plants, right? As an example, right? You may not need to go, become ready to be a Pratt & Whitney engineer if you needed to be, but you got to understand it enough to know what's the relationship between my aero design and the power plant that is going to propel it. As an example of the adjacencies, you need to have some awareness of the things, and I would start with looking at what is the adjacent things that are affected by or influenced by, one way or the other, the thing that you're going to be focused on.
So I was wondering, what were some of the difficulties working in the military as a civilian?
What's that?
What were some of the difficulties working with the military as a civilian?
Difficulty. It was an honor, quite frankly, working with military. Now I will tell you that working with the U.S. government, which is different than working with the military. When I would think about when you say working with the military, I think about my customer. I think about the warfighter. I think about the pilots, the airmen, the maintainers, etc. Pleasure, absolute great Americans, just generally solid people. However, working with the U.S. government, slow, tedious, paperwork to make your eyes bleed is absolutely just, that's tough. It's changing. There's a different spirit inside the Pentagon these days relative to how do we get more like Silicon Valley and modern technology and more commercial based. It's going to be a long road. We'll see if they wind up where they want to be. But there's a big move afoot to change the course of the way they specify, procure, and maintain and sustain programs. But that's been the part that my commercial brothers and sisters that I know on the commercial side, they're like, that's no thank you, right? Because they do stuff at the speed of business, and U.S. government does things at the speed of smell. I mean, it's just that's the difference. Yes, please.
Based on your experience with managing teams and everything, where would you weigh for your experience in like projects, research, or internships over each other?
That's an interesting question. Now, today, projects, because that gives you technical, team, interpersonal, and interdisciplinary all in one fell swoop. Before, you have to show up at your job or you first to start that. I think interns, you know what I most like about internships from an intern's perspective? It lets you sample the company. And typically, internships aren't one role. You're just going to go do this one thing for 8 weeks, 10 weeks, or whatever, and that's it, right? They usually kind of move them around. They take them on little field trips. They put them on we used to put them on the corporate jet and fly them out to Lake Charles, Louisiana to see what manufacturing looks like and bring them back to things. They get to go to R&D events. Because they wanted to get that exposure. So I like internships early career a lot. So that one kind of, I would say project work now, but internships is not a bad way because it gives you a chance to look beyond this in the early days of a career. And you can decide whether to, even if that company's for you or not, quite frankly, because there's nothing wrong with being an intern at Lockheed and becoming an engineer at Boeing. Nobody's going to, well, that's heresy. No, there's nothing wrong with that. That's fine. Yes.
In the spirit of one of your previous answers to one of the questions,
yeah.
I'm interested in pursuing a master's in a different engineering discipline than my undergrad. How would that affect my career? Because I'm interested in control systems specifically. Because I'm doing an undergrad.
Enhance. You know, it would enhance it. I started off with more of electronics bent, communication systems, networks, RF theory, right? And ultimately worked into aero and then big systems design. And all of them, because you become automatically multidisciplinary, right? So the only downside to that is there anything in your undergrad that now won't serve you as you go for your advanced degree because you didn't take some of the underpinnings. You'll have to evaluate that as you decide on your course for your advanced degree. I got my master's degree in technical management because I knew that was my path, right? But I didn't want to get an MBA because I was never going to become a business person. I always wanted to stay on close to or involved with the engineering, the product, or the performance of the product. So I stayed MS when I went through my master's, but building on it, although it was different, right? So the technical management degree, this is a different question you're asking, but my own frame of reference is aeronautics, electronics, aeronautics, and then management. Put them together, and people are like, yeah, this guy's got brains. So as long as you do it right, and you don't wind up losing something in your undergrad or missing something in your grad degree, as long as you have those bases covered, you'll be better off for it. Say again? Well, it depends. If you're talking about one of the big primes, then for those you have to kind of divide them into air breathing or space, right? So if it's air breathing, aero design still a hot item, but what's even hotter is microelectronics and AI and software-defined radios and advanced networks and radar aperture design, RF theory, kind of thing, because there's not as many new airplanes as there used to be. Right now, they're F-35 is the airplane for the Navy, for the Air Force, for the Marine Corps, one airplane, right? So it's not like everybody's always designing the next airplane. Not that aeronautics is off the board, because it is not. There's always going to be the next, right? As a matter of fact, we'll just, there we go. Speaking of next, that's our latest. That and James Webb, by the way, were two of the shining accomplishments of Northrop in the last decade. Good stuff. But so on the hardware side, there's still material sciences. There's still advanced design ideas. Networking is advanced networking and secure and encrypted networks, kind of thing on the engineering networking side. That's always pushing the boundaries of faster, more efficiency, data structures, et cetera. And then on the hardcore design side, the area of low observable or hard to detect designs, whatnot, is what it's all about. Whether you're a jet or whatnot. On the commercial side, it's efficiency, right? You're trying to get, X number of people from point A to point B as cheaply and safely and comfortably as possible. So cheap, safe, and comfort are the focuses there. So that's material sciences and fuel sciences and all that, and engine propulsion science, new technology. So it depends on whether you're talking about commercial or military, space or air breathers. But that would give you something to think about.
In all of your experience, when hiring a new team member, one that you're working closely with, what is the most important thing you look for?
Fit. Does this person fit the team? And it's not just personality. It's how they communicate, whether they're respectful or passive or just dismissive of other people's input because they're the smartest guy or gal in the room, or are unwilling to ask questions because they're too afraid of exposing they might have a weakness. Those are all bad things. Show up, be yourself, respect everybody in the room, be a team member, ask good questions, support your team members when you can, and you'll be the head of the line. Next time go around, I want you on my team. And it's like, oh, yes, yeah, he's technically good too. Because you can get good technical acumen is not the hardest thing to find. If you need someone who's an expert at it, the list goes from half the engineering population in a place like Northrop down to 6 people, right? There are very few people in particular discipline, even in a company that has 90,000 employees, who's absolutely expert. I'm talking about true, science level, can do math, got the whole just down to a thing. Is a very, very, very small group of people, which is both good and bad. So if you want to become one of those people will put up with a lot of personality quirks. Oh, you got to call Dr. Dale. Oh, okay, all right. We got to be ready for him because when he shows up, things are going to go sideways. But he's the only one that can solve the problem, and that's a real person, by the way, and a real story. But be that as it may, I would say fit is and how you would integrate with the team is what I would put really, really high up on the list. I got 11 seconds. Sorry, Amelia. Any last questions?
Compare what your most valuable resource in college was to what your most valuable resource is now in terms of work, why you're still in the aerospace industry.
My network. So during time, and so during the time during my career, the fact that I got to know a lot of people across the company helped me through ways. Go ahead. Yeah.
What was the way that you maintained your connections?
Sure.
30 years.
Sure. Absolutely. Yeah. I'm happy. I was going to touch on that. So it let me know who to call when I got stumped because I knew who would be one willing, two able because if they've got the right kind of background and they're better at me at pick a thing, whatever the thing where I'm dealing with, and it's someone that I. These days it's a whole lot easier. Before it used to be a phone call here and there, and then along with this little nice little invention called email came along. Then it got a bit easier. Then along comes the internet. Now I've got almost 6,000 connections on my LinkedIn, and about 1,000 of them are people that I know personally and could call and help me solve a problem today. Right. The others are secondary and tertiary people that know people, I think. Right. But my network has been my most valuable resource I've been maintained. Technically, I would have to say some of my early lab experiences, hands-on kind of lab experiences where I didn't know enough to know enough at that time. I learned so much. My learning curve was such steep at that time that I still remember a lot of things from the early days. Hard lessons learned in the lab because I didn't know any better. Later on, when it got easier, it was still difficult work, but I got really good at it. So I learned more in my early days when I didn't know shit, rather than later on when I kind of got good at stuff. So not to miss. Go. Yep.
What would you say are things that freshmen or new incoming students should think about or do to have a great impact on life and preparation?
So at the risk of being repetitive, This project work that they all briefed earlier, I can't endorse enough. I didn't know about it, quite frankly, until I got here. I can't endorse that enough. Get involved. And it does, you don't necessarily, quite frankly, well, since I'm going to go into rocketry, I can only be on the rocket team. That's not what this is really about. It is subject matter what it's about. And you might line up with something that you are interested in, fine. But to me, it'd be more interested to get involved with something that is challenging to you than necessarily being something is perfectly aligned with your career goal kind of thing, right? Because you'll learn group skills, team skills. You'll translate some of your early academics you're going through right now into what it means to an airfoil design, right? Yeah, okay, I did the math and I got a B on my test, but now they say, oh, I got to build one, a design one. Wait, hold on, I got to now turn that academic learning into something real. So I would say, look for opportunities to apply your academics in a real way, and then also let that inform your class selection going forward. What you find, you're going to find acumens, you're going to find things you like or are good at or have a knack for, and don't be afraid to follow those leads. And they'll talk to you. So you'll learn them along the way. I did anyway. So last before she kicks me off here, in the middle. I did so much. At times, so I'll say this, I had an opportunity to become the president of a division at a company called Telephonics, a big company out of New York. And they tried to recruit me to become a division president of the communication system division at Telephonics. And my loyalty, because I'd been here so long, and this was, I bled Grum and Blue kind of thing. I was a very, very loyal guy to a fault, because I wound up passing on that opportunity about a decade later kind of thing, when I wound up with the wrong team and got kind of pissed off that I made a bad decision because something had gone, I'd make, the regretted decision. It made me say, I probably should have thought twice about turning them down. Make sure that the career path offered is a balance of what's good for you, good for your family at the time, and good for the holistic good, if you will, instead of just what you personally think. I made a gut reaction decision, and I didn't make a holistic decision. I probably would have come to a different conclusion, and I have some regrets about that. So, there, one more.
One question.
Yeah.
Do you have the idea to be like a field engineer and then like your early career days and then try to transition?
I mean, not necessarily. I'll tell you why. It's easy. Once a field engineer, always a field engineer. You get kind of branded a bit, right? So the only way I was to break a field engineer tag on my back, if you will, that was kind of my brand, right? I shifted divisions, programs, customers, everything. I went from the Hawkeye program to the Navy, from the Navy Hawkeye program to the Joint Stars Air Force program, from New York to Florida. I mean, I broke everything and went completely different direction. And that's what got me on the hard engineering side, because they accepted me as just a good engineer. Where my community of practice that I've been in, even when I did go into engineering, they knew me as that field engineer guy who was doing engineering, right? So for me, it wasn't, I'm not saying it was a bad experience. For me, it was a very good experience because I learned a lot during those early phases. But many of the engineers that I dealt with were engineers at the factory who would come out to the field, help solve a hard problem, and go back to doing their engineering. That's a better. So if you got an opportunity to go to the field, whatever product you're on, definitely raise your hand and say, I want to go out to the Yuma proving ground out in the desert and chase scorpions and tarantulas around and try to fix the thing that I just designed. That's a great opportunity. I don't know that field engineering for a hardcore BS, whatever your background might be, may not be your best, in my personal opinion. Okay, that's it.
Let's give a round of applause to our speaker. All right, so this is that QR code we were talking about during the presentation earlier. It has our link tree. It has all of the project interest forms. So if you're interested at all, definitely fill those out. And we'll be starting project meetings next week. But that will wrap up our general body meeting for today. Thank you all for coming.